Mathanionis. Oh,
There you
there
go.
we go. There we go. All
That's
right.
fine.
So yeah, my name is Mathanionis. I'm a regional sales manager covering the Eastern Territories for Thermal Corp. Thermal Corp, we're a custom air handler OEM out of Houston, Texas. We've been around for 75 plus years. We're really big in the oil and gas industry with air handlers in the past and have moved over to more of the commercial side, still doing, oil and gas, offshore rigs and stuff like that, air handlers as we're located in Houston, but we're into data centers, hospitals, schools, you name it, anything custom, we're building it. So it's just a little information on thermal. Myself, degree mechanical engineer. I started working with Thermal Corp in October 2021, so going on my fourth year this year, and have been in the sales side since I started. So gotten to know custom air handlers pretty well. In today's presentation, we're going to be talking about the different technologies and different facets, products of custom air handlers. Um, so, excuse me, to start off, we'll be talking about custom air handlers and why you would want to select a custom air handler. So there's various different reasons that are going to drive you into your selection of a custom air handler in your application or project you're working on. So the first one being you're going to need engineered solutions specific for specialized applications. So hospitals require very specific applications. Some schools, big universities, they require specific applications. If you need to get through certain openings, the ingress into the building is probably not going to always be a new construction if you're doing a retrofit, things like that. Anytime you kind of start getting away from a standard catalog option, you're going to be driven toward custom. And another reason is going to be special materials. Once you open a catalog, galvanized casings, uh, foam insulation or fiberglass, you're kind of limited in what you have. So if you need special insulation for things like corrosion protection, if you want to go stainless or aluminum, for those reasons, sometimes that's going to drive you to a custom solution versus a catalog option. Special flow path configurations and specialized size fit. So if you have energy recovery, a heat wheel or a plate heat exchanger, or maybe even a heat pipe system that goes to your return and supply air streams, you're going to need special flow path configurations, meaning you're going to need two tunnels in the same cabinet, either top and bottom, side to side, maybe even a triple deck. Maybe you need a full vestibule on your unit because you want to protect all your piping and your electrical and have that enclosed in a cabinet. So even though air is not really flowing through that second tunnel, it's a special flow path configuration, which typically isn't offered in a catalog option. So you're kind of be driven to a custom solution there. Specialized size and fit configurations. That's again what I touched on. If you have a certain ingress into a building, if you have to go through a double door, if you have to go through a louver in the building and a catalog unit for that size capacity, it's too big. You can't break it down into sections for shipping or getting it into the building. Again, that's going to drive you to a custom selection because custom, you can knock them down completely, take out the panels, take off the frame. Sometimes you can even knock down the base and the floor to get it through up stairwells, up elevator shafts, through standard doors, 36 by 72-inch tall doors. Those come up all the time. We see them all the time here at Thermal, where we have to sectionalize our units, get them to fit through whatever opening they get to, and then once they're in the space, you can put them back together, knock down, take it all the way down, like I said, get it up the elevator shaft, up the stairwell, then assemble it back in the space. So those are going to drive you to away from a catalog to a custom solution because a catalog option isn't going to be suitable there. Sometimes they do have a palletized application, but again, that might not be the best solution for what the challenge that you're facing. And then again, specialized components. If you need heat recovery, heat wheels, plate heat exchangers, heat pipes, electric heating coils, special filtration, humidification, humidifier grids, whatnot. There's so many different products and components that can go inside of an air handler, which you open a catalog, you got a coil, filters, and fans, and you're kind of limited on what you have. So if you're needing any of those special solutions there, you're going to be driven to a custom option. You'll reach out to Holden and ask them, do you have a manufacturer that can do humidification and energy recovery in the same unit? And most likely you're going to be given a custom solution there. because the custom guys are going to be the ones who can handle that. Specialized construction methods. This also is kind of touches on the specialized size fit, but also the actual construction of the unit, the construction of the cabinet, the panels, even the base, can get down to those minute details. If you need a welded frame unit, many catalog options aren't going to have a fully welded frame. If you have to have fan exhaust sit on top of a unit, you might want a welded frame to support that weight, or if you want a thermal break, you got to have, special considerations there and how your panels are put together and your frame is put together and all those different things. So, again, just another thing that's driving you to a custom air handler. And then size and pressure ranges being one of the last details. Uh, when you open a catalog, it's a table. You got up to 10,000 CFM, whatnot, up to a certain size pressure rating. With custom, we can do different fan walls, different fan manufacturers, go different components. So you're not really too limited on the CFM that you can do in the static pressure. There's a plethora of different options that you have in that category. So these are just all the different reasons that are going to be driving you to select a custom air handler. So now touching more on the actual products and technologies in custom air handlers, we'll start with the casing and framing of an air handler. So there's kind of these four categories that I broke it down into, that are different technologies related to those. One being the thermal break, then the insulation that you have in your panels, the different liner materials that you can choose for your interior and your exterior and your roof of your unit, and then also the construction methods of how the unit is built, how the frame is put together, how the panels come together, and things like that. So to touch on the thermal break, what exactly is thermal break? It's just a term that basically means that you have something in your unit that's used to mitigate the heat transfer from the exterior to the interior of your unit, just to prevent heat loss, to prevent condensation or sweating occurring on the outside of your unit. So what I have here is just an image of one of thermals. Actually, it's a frame for one of our construction methods. It's called a TS unit. We use an extruded aluminum frame, and you can see in the first image, it's a hollow, extrusion. You can see the pattern there. And in the second image, you can see that it's filled with that black substance in the middle. That's polyurethane. And then in the third image, you can see that this slot right here is milled out. So these two flanges that are on the top left of the corner post or the frame member are in contact with the interior of your unit. So in the beginning, first image, and sorry, the bottom right hand is what's going to be the exterior of your mechanical room or whatnot. So in the first image, without any insulator filling the aluminum is a good conductor of heat. It'll transfer heat pretty well from the exterior to the interior where that cold air is touching and cause sweating on your frame. So you fill it with an insulator, polyurethane to add a thermal break between the metals, but you still have that piece on the left, which is there's still a continuous path for heat to transfer through that metal. So then what we do is we mill out this piece all the way down the length of it so that now there's no continuous metal to metal heat transfer, and you have a full true thermal break. Now, this is just one way that thermal does it and one frame option. Many manufacturers have different methods, but that's really what a thermal break is. You're wanting no continuous path for metal to metal heat transfer. And this is just talking about the frame. There's also different things to consider with your intermediate posts, because these are going to be your corner posts. You have intermediate posts along the length and width of your unit and the roof. How the panels come together, you want to make sure if you have a two-panel system, you have gasketing and insulation in the panels and gasketing where the panels touch. You don't want your fasteners to go all the way from the exterior to the interior of the unit and provide another path, because those fasteners will condense in an unconditioned mechanical space. You're going to have water condensing on the outside of your unit. So that's just one of the technologies in air handlers. You see this all the time in specifications. Unit must have a thermal break. There must be no path for there must be no metal to metal heat transfer, and that's really what they're talking about here. And then next to touch on the different insulation options. So we have injected spray and spray foam insulation and fiberglass insulation. These are the two most prevalent insulations in the custom air handler industry. The picture on the left is one of the bases from thermal showing spray foam insulation. You spray it in, let it rise, and then we'll seal it off with a sheet of sheet metal over that. And with an injected, there's a you use a foam press, put the panels in there, inject it, and you know cure it. Pressurize the panels together and cure it for insulation. And then fiberglass, it's just you put it in the panel and then seal it up. And there's a couple different things to consider when you're just looking at these two different insulations. Foam insulation is going to have a better R value, going to be better at preventing heat transfer, a better insulator. However, if you have applications that are sound sensitive, hospitals or universities or things like that, you might be leaning toward fiberglass insulation in your panel because while it doesn't have as great of an insulation or R value as injected foam or spray foam, it's going to be better at insulating sound. For those applications. And there are also different things you can do where you can put an additional perf panel, which is where you just take perforated sheet metal, you put some fiberglass insulation behind it and put it on top of your panel on the inside of your unit to add sound insulation. So say you had a two-inch construction unit you want a good R value, so you go with foam insulation, but the fan is where the most sound's going to be. So you're worried about that. You can add in that section just on top of those 2-inch panels, and then you'll have 3 inches in that section, 2 inches of foam with your inner and outer liners. You always doing double wall construction nowadays, so you'll add in on top of your inner liner 1 inch of fiberglass insulation with perforated sheet metal on top of it to help with the sound attenuation in that section. And moving on to the different liner materials. So there's many different liner materials. Standard and custom air handlers is going to be galvanized, especially for indoor units. In these pictures, you can see on the inside of the unit on the left is that white material. That's just a pre-painted white galvanized material. And on the right, you can see it's stainless that has a covering over it to protect it during handling in the shop and shipping so that it doesn't get scratched up. But there's a lot of different options to consider. You can do tread plate on your floors, 1/8 inch or 3/16 inch tread plate for access with large units that you're walking in. You don't want the servicemen, going in there and slipping on it and falling. It's more of a safety thing. With the tread plate floors, you can also do what we call wash down floors, where you'll take that tread plate and you'll upturn the lip on the collar and have a 2-inch collar going around the perimeter of the floor. And in each section, you can put a drain in there so that during maintenance or maintenance of the coils or whatnot, you can actually go in there and wash down the unit, spray water, wash it down, squeegee it out through those drains in each section. We see that a lot in hospital applications where they require that. You can do aluminum liners, stainless steel liners, galvanized liners, paint the exterior. A lot of different options to consider there with your liners. But again, that's another thing that's driving you toward a custom solution. If you were to need an all stainless steel unit or an all aluminum unit, you can go with brushed exteriors for aluminum and stainless steel. We typically recommend that on your units because when a manufacturer is handling all that sheet metal, bending and cutting it for panels, if you have smooth stainless steel, it's difficult to not scratch it up in handling. So with a brushed or maybe even an embossed exterior, you already have that pattern in there, and it'll look a lot cleaner when it comes out. A final product. Just different things to consider. And lastly, touch on the construction method. So these are just two different construction styles from thermal. You can see the two different frames, panel constructions, and bases. There's a lot of different things to consider. These ones are not welded frames. The one on the left is going to be a formed frame, and the one on the right is going to be that extruded frame. And you can kind of see the extrusion, sorry, that I showed in the images before. This is just a highlight on the many different construction methods. Even with custom manufacturers, most maybe have one or two. And these are just two of our construction methods. Thermal has 6 different frame and panel methods that we can put together to meet different needs. Not shown here, you can do a welded construction. Again, like I was talking about before, if you were to have plenum exhaust fans, we'll have exhaust fans that you need to put on top of a unit. those are pretty massive, pretty heavy. You want to have a welded frame to support that weight. If you were to have a dual deck unit with a redundant, we've seen units where they're just redundant units, one on top of the other, and you have pretty massive coils, 8-row chill water coils in the top section. You want to make sure you support that weight properly. So you can go with these constructions and just, beef up the unit, add more support, or you can go with the welded frame to take care of that. Another thing to consider that I talked about earlier as well was the shipping splits or knockdown construction. If you got to get into a tight space, if you got to get through a door, you want to make sure your unit can be knockdown capable. It'll be built in the shop, fully assembled, enough for shipping and handling, and sent with minimal screws, no caulking, gasketing, so that once it gets on site, the contractor can look at the unit, take it down as they see fit, and as they take it down, they can then know how to put it back together and get it into the space and do what they need to do. Shipping splits, same thing. If you don't have to knock it down completely, maybe you have a louver or something you can get into through the building, but it's still not large enough for the whole unit to come through one piece. You can split it up into different sections and get it in there, and then just fasten those sections together. And then just for shipping as well. That's why sometimes they call them shipping splits or demounts or sectionalized units. Um, Different constructions allow different ways to split that unit. Even some custom manufacturers don't have a way to really split their unit. You have to do it in one piece. And most catalog options are all going to be one piece units. So depending on the size of it, there are different restrictions with shipping. Once you go over 100 inches in width on a flatbed trailer or a double drop, single drop, whatever it is, you got to get a permit. So different ways to work around this is to split the unit up into less than 100-inch sections, get it on that truck and turn it so then you don't have to get a permit for shipping, saving on shipping costs and things like that. So moving onto unit openings, these are different products that can go on a unit. You have control dampers and actuators, which are very closely linked. Your control dampers are going to be controlling the air that goes in and out of your unit, controlling the pressure and CFM. You need to select the correct actuator to open those, and you got to pay attention to the actuators. Usually, this is handled by the controls contractor, but a lot of times, a custom air handler manufacturer can provide your actuators for your dampers on the unit. And things to look out for are with outside air dampers, you have to be careful because those typically require more torque than a return damper because with the outdoor air coming in, you have grime, dust, and different things that's going to jam up the damper, and you'll need more torque on that actuator to actually open it over time. With control dampers, different things to look out for is the frame, if you needed an insulated frame, insulated blades, and not just control dampers, but even backdraft dampers on fans. You want to pay attention to the construction of those. And if you have a fan array, typically you want backdraft dampers to prevent backflow if one of those fans were to go down. Um, Sometimes we see it in the past, you just provide a blank off plate. Someone would go in there and just blank off that fan opening if that were to go down, but a backdraft damper is more of a foolproof method and doesn't require someone to go in there and actually do that. Louvers and rain hoods with outdoor units, you got to have some way to prevent water and from getting into your unit, into your opening. If you're not on a roof curb with a floor opening for just return air or a ducted outside air opening, you need to have a louver or a rain hood to prevent that. And with louvers, you want to go with the drainable louver a wind-driven drainable louver so that the rain is not getting into your unit. And you also want to pay attention to the size because louvers have free area. So typically around 40 to 50% free area is what is going to dictate the face velocity. And once you typically get above 1,200 feet per minute through that free area, what the manufacturer will state, in their submittal on the louver that after 1,200 feet per minute, you can still get water ingress on a wind-driven rain louver. So you got to kind of pay attention to that as well. And then rain hoods are just in the bottom picture, you can see a rain hood. It just is going to prevent the rain from getting up in there. And you can put an insect screen on there too and a bird screen to prevent any animals or insects getting inside of your unit because that is an issue on outdoor units. And with unit openings, lastly, to touch on it was outside airflow measurement systems. So we work a lot with Eptron. I'm sure you all have heard of Eptron before. They make dampers with outside airflow measurement systems built into them, or they make the systems where you can insert it into your air hood, into your louver, or ducted into your unit and have their airflow measurement pair into it. And those are just all different technologies or products that you can put on your unit opening, the inlet or the outlet, any unit opening that you have. And just kind of related to it is going to be mixing devices. So in cold weathers and not just cold weather, but it really happens in cold weather, you get stratification in air handlers. So the air is not going to mix properly, and this can cause issues with uneven loading on your filters, on your coils. This causes hot spots on your coils where some parts are working harder than the other, and it can drive up the face velocity of that hot spot if more of the air is going through that section or through other sections, causing carryover and different issues. So different ways to kind of tackle this issue is with mixing boxes where you have two different openings in your unit to push the air against each other and and mix the air. You can kind of see it in this image before, sorry, to the left, where you have your hot outside air and your cooler return air coming in. And if sometimes when the outside air is too cold, you're going to have really big issues with stratifications and mixing boxes aren't enough. So two different technologies that thermal uses and many manufacturers use to counteract this is going to be air blenders and channel blenders. So an air blender is just bent sheet metal into different shapes, into these curved shapes that you insert into your airstream, and it looks like this on the left, and it's going to just mix that air a lot better and prevent stratification and prevent those hot spots and uneven loading on your coils and your filters in your unit. It can help with freeze protection and indoor air quality. It helps with like sensors in your unit. With stratification, you're going to have different, as you can see in that image before, different temperatures at different heights in your unit. So it'll help with sensor errors and improve your temperature control in your building system. And one kind of drawback with this one is it takes a lot of downstream mixing distance. So you have to have the proper clearance downstream of the air blender to get the air to mix properly. So if you have enough footprint in your mechanical room, or if this is outdoor unit on the roof or wherever, then this is a great solution to that issue. But if not, these are both, again, I didn't state this before, but these are made by Blender Products out of Colorado. And to kind of tackle that issue of the footprint required for these air blenders, they came up with what's called a channel blender. And these mount directly up to the openings versus the air blender is going to be mounted in the duct downstream of that mixing box. So you'll still need a mixing box, and then you'll put the air blender. With the channel blender, this mounts directly into the mixing box. So the top opening and they come in different configurations, not just top and end. They could both be left and right or bottom and top, whatever. They're pretty custom. But these do the same thing. They do mix the air better. They have dampers in them that require actuators to modulate, but they are more efficient in how they work. And they reduce the footprint a lot of the unit. Sometimes with these air blenders, depending on the size of them and the quantity you have in your unit, you can need 4 or 5 feet upstream and downstream of that air blender to have the proper mixing of the air and prevent stratifications. But with the channel blender, you typically only need less than 3 feet after it to have proper mixing in the unit. So you save a lot of footprint on those. Moving on to air treatment technologies. So we're all familiar with fluid coils and refrigerant coils. These are the main technologies that you use to treat the air, heat it or cool it or dehumidify the air. There's direct evaporative cooling, energy recovery. Typically going to be a heat wheel or a plate heat exchanger that's used. There's some other technologies as well. Alternative heating, just meaning electric coils and indirect gas heat used in different applications. So breaking this up into the different categories there, we have coil types. So the different types of coil. Fluid is going to be your main coil that is in most custom air handlers. Refrigerant coils, steam coils, and runaround or wraparound coils. So fluid coils are your standard coil finned into with water or a glycol substance running through them it's just a heat exchanger, as we're all familiar with. Refrigerant coils is the same situation, just different refrigerant instead of fluid, it's going to be refrigerant running through that coil. Steam coils you see in the top right picture. There's a steam coil with electrofin coating, a corrosion type of coating there. So if you have steam at the facility that the unit's going on, a lot of times for heating, I see this a lot of times in Michigan. They use steam heating coils for heat instead of water coils because like they have steam on demand a lot more up there that I see. Run around and wrap around coils. These are kind of energy recovery devices or dehumidification devices. The wraparound coil on the bottom middle of the image, you have the cold air coming in, or sorry, the hot air coming in, and you dehumidify it a lot, and you get another chill water coil actually is going to be sandwiched in between there, and then you cool it and dehumidify it more, and then you can reheat the coil, or sorry, reheat the air to the design temp that you have there. And that coil is actually going to be a closed system. So the heat pipe or wraparound coil here, or also called the heat pipe coil made by Heat Pipe Technologies, is a closed system. You design it with them, give them the parameters. It's charged with refrigerant, and it just works on its own. There's no electrical or mechanical components in there. It just uses the change in phase of the refrigerant to heat and cool the air. And the same thing is happening with the runaround coil up top in the middle. That's going to be in two different airstreams, but it's just charged with refrigerant, and it uses the change in phase of the refrigerant in there from a gas to a liquid to heat and cool the different airstreams. So those are pretty common technologies that we see for energy recovery if you have two different air streams and want to treat the air with coils. Those are what we see a lot. And with these coils, there's different accessories to look out for: UV lights, coating, mist eliminators, coil removal racks or individual coil removal racks, and drain pans. These are all pretty key components on units. So I had that image before, that steam coil. So that has coating on it, and it's sitting on coil removal racks. So coil removal racks are really just to have individual access to the coils. If you want to remove that bottom coil, you're not going to have to remove the top coil. And with high CFM units, you get pretty large coils, so we want to split them in height to make them more manageable for maintenance and handling in the factory. Once you start getting two coils, three coils stacked, if you don't have a removal rack, they sit on top of each other with their stacking flanges. And if you needed to move that middle coil, you got to get the top one out. If you wanted to remove the bottom coil, you got to get the top two coils above it out. So we just put them on stainless steel tubing, 2x2 by 1/8 inch stainless steel tubing, make a frame around the coil, sit it on top of there. We see that a lot for different hospitals, and universities require that for ease of maintenance of the coils. If they were to have to be replaced or anything be done to the coils, it makes it a lot easier. UV lights, we see them a lot on chill water coils. Any coil that has condensation on it typically is going to require UV lights on it to prevent any growth from that condensation happening. Mist eliminators, if you have high face velocity with condensation, there is a chance for water carryover to get onto the next component, whether that be the fans or filters or whatever is downstream of it. If it's something you don't want to get water on, mist eliminators can, kind of solve that solution if you were to be at a high face velocity due to size constraints of the unit or a space that you have the unit to be in. So you could put a mist eliminator downstream of that coil to catch the water and put it back into the drain pan, which is the last item on the list. Any coil that has condensation needs to be in a drain pan. You can't have standing water in the unit. It's going to lead to rust and a lot of problems down the road. And energy recovery is another way to treat the air. Typically, we see these with heat wheels and plate heat exchangers. So heat wheels are going to be high efficiency, and depending on the actual media of it, they can transfer both latent and sensible heat, or do it individually latent or just sensible. There are a little more to maintain just because of the moving parts, but they kind of make up for it with the fact that you can do latent and sensible heat, and they just have a better operation over a larger temperature range or differential between your two different air streams. Plate exchangers are fixed. They have no leakage or carryover because of that. A heat wheel, since it's a rotating piece of equipment, you can't 100% seal it between the two different air streams. Typically, what the different heat wheel manufacturers provide And the casing of the wheel is just brush seals between the two airstreams because as it rotates, some of the air will go, depending on your pressure differential between your two return and outside airstreams, there's going to be leakage depending on that pressure differential. And that just depends on where your fans are put in your unit, if it's going to be positive or negative pressure on the face of the wheels. And here you want to watch out for making sure that your outside air is going to be getting pushed into your return air and not the opposite way, because you don't want the return air, which eventually is going to be getting exhausted, to leak into the outside air and go into the supply air. So different things you can put on a wheel. The main thing you can put on a wheel is a purge sector, which is just a piece of bent sheet metal. Depending on the pressure differential between your two decks and the position of the fans in your unit, it will kind of dictate how big that purge sector is and what side of the wheel it'll go on. But all it does is it helps push that outside air into the return air and prevents it from happening vice versa, where the return air gets into your outside air. And you don't have that issue with plate exchangers because these are just fixed heat exchangers that are sitting in the unit, so there's no leakage or carryover in those systems. They really only do sensible heat transfer. There are different polymer medias that you can make the plate exchangers out of to do sensible and latent heat transfer. But most of the time, since they're aluminum plate exchangers, it's only going to be sensible. Little to no maintenance, but they do typically have a higher pressure drop as they're bigger pieces of equipment that are going to go inside your unit. So moving on to direct evaporative cooling. Uh, some people, like to call it free cooling. It's low energy use. And for these reasons, it's great for data center applications, but it's really ideal for hot and dry climates. And it kind of does have high maintenance because you got to clean your media out a lot. And this isn't really applicable to the Georgia market as we know how humid it gets there, but in drier climates and for data center applications, it's a really good cooling method as you just spray the water over the media, and as the hot air passes through it and evaporates the water, you use that latent heat of evaporation to cool the air. But depending on the water quality, you got to clean up that media a lot. And these systems can get pretty complex with pumps and actuators and UV lights for the water, conductivity, sensors for the water as your salinity and different things get higher. That's going to tell you the water quality and things like that. Touching on alternative heating methods, we have indirect gas heating, high efficiency, typically around 81% efficient. This is the image below is one from Heatco, which is based out of Georgia. That's who we use for all of our indirect gas heaters. And then we have electric heat. That one's image below is from a Naylor duct heater that we put in one of our units. They're high efficiency as well, but they require a lot of power because you're putting all that electrical energy into heating the unit. But they're usually ideal for smaller spaces or smaller heating loads because the higher the load, the bigger the resistive elements, the bigger the electrical demand on the unit is going to be. For indirect gas heatings, they're really good for larger heating loads. And we typically see these for battery plants or industrial applications because they have natural gas supply already on site and they have a high heating demand. So this really works well for them. We've done one for a lot of units with these for a Mercedes battery plant and other different industrial applications throughout the country. So touching on fans. So we have two different technologies that Thermal uses, and that's pretty common throughout the custom air handler industry. So Platinum fans with AC induction motors are going to be our probably our bread and butter. 90% of what we do is with these, and that's just because what is in the market right now. EC fans are the other technology that I'll touch on here, but the market isn't really calling for those that much. So not just Thermal, but many other custom manufacturers don't use them as much. But we see these in elementary schools and high schools and some colleges a lot where they'll want these EC fans. They're high efficiency, they're better efficiency at lower speeds than these Plenum fans. They're compact design, so they're great for retrofits. If you have just a fan wall retrofit where you have to replace it in an existing unit, typically ECM fans are going to be better for that. They're easier to install. Just put the bulkhead wall in, and with the manufacturer we use, they kind of have what they call a spider bracket. You just pick the fan up, get it on the wall and bolt it into place, and they're really easy to put on. Versus you can see in the bottom left are these large fan cubes for AC induction motors. And but the thing about AC induction motors is they're going to be at a higher CFM and static. You got different isolation options: restrained spring isolation, open spring isolation, or rubber and shear isolation. And these ones are more readily available for component replacements. If you need to replace the fan wheel or the inlet cone or the motor, ABB and Toshiba are two major manufacturers of these motors, and they're standard NEMA frames. You can swap it out with different manufacturers pretty easily. Versus on these EBM fans, they're more custom specific components with their circuit boards, so it's a little more difficult, but they do provide a great integration with the BMS. You can pull a lot of information from the fans and use those to make your system more efficient. Additional components in air handlers are going to be doors, and with the doors, you have your frame, handles, and hinges, windows, and interlock switches. Um, Here's an image of a door that Thermal makes. We use an extruded aluminum frame, and we have that same polyurethane that's going to be in between the door frame in the middle that provides a thermal break. Um, you have two gaskets, a bulb gasket on the door frame with the foam gasket on the back of the actual door. And this is to prevent leakage through the door. And any custom air handler, your door is going to be one of your main sources of leakage. So you want to make sure that you have a good method to seal the door. Um, and we do that again with those two different types of gaskets. As they sandwich against each other, it really forms a good seal and prevents air leakage. What I was talking about with the frame earlier is for that thermal break. You don't want there to be a chance for condensation forming on the frame of your door. So you want to make sure you have a good thermal break there. Handles and hinges are pretty standard, but they can, get not really complex with depending on the size of your door, how high up your unit is. If it's on a roof curb and you have a tall door with three handles, you can link those handles together on the inside of the door, so your maintenance man doesn't have to get on, a 10, 12, 18-foot ladder and unlock all three handles. You can just pull the bottom one as they're all linked together and open that door. Hinges are pretty standard. You want to make sure you have a good hinge as well, and that's adjustable in the Z plane, not just the X and Y plane, to get a good fit on the door and good compression again to prevent leakage happening through that door. And then interlock switches are for safety. OSHA requires there to be some means to de-energize rotating equipment when you're accessing it. In the past, this was done a lot with cages over fans and inlet screens. And with interlock switches is a really simple and effective way to meet that requirement. You can just open the door and the interlock switch opens the circuit, it de-energizes that fan. Same thing with UV lights. You have to have some form of protection. You can't go in the unit with the UV lights being on, as it will damage your eyesight. So an interlock switch just does the same thing. You open the door, de-energizes the UV lights, and makes it safe. And these are required for any piece of rotating equipment or UV lights. So any custom air handler manufacturer is gonna need to have some means. Maybe it's not with an interlock switch. Maybe it's with an inlet screen on the fan and a protective screen on the outlet of the fan, so that they can still go on with it running. But depending on the size of the fan, that protective screen on the outlet can get pretty big and pretty costly, pretty heavy. So an interlock switch is just a simple means of replacing that. Airflow measurement is a kind of a big thing with supply fans or return fans, fan array systems. You want to measure how much supply air you're getting. You want to make sure it's what's scheduled, what's up to code. You can see in the two images on the right, there's a panel with an HMI screen kind of showing a fan array, and in the bottom picture is what's on the inside. So Thermal we make our own one with Distech controllers and Dwyer pressure transducers, where we just run tubing from the fans to get the pressure, run it through those Distech controllers with some programming to output CFM for the total fan array. There are a lot of different manufacturers. One major one you may have heard of is Paragon. They make a system called a FATS, FAATS 1000, and an MTSE, which essentially does the same thing, just measures the supply air coming out of your fans. I talked about it at the very beginning. Eptron also makes the same thing for outdoor air. They integrated with their dampers so they can sell you the whole assembly or just the measurement system that you can integrate in with yours. But these are two things that are pretty key, and we see these a lot more nowadays with custom air handlers to make sure that you are getting the flow that was scheduled, that was submitted, and make sure you're meeting code with, minimum outside air or the supply air that's going through the unit or the exhaust air that's getting exhausted out of the building. So if you need those, those are really going to be available with custom manufacturers. So lastly, I'll just touch on this is a kind of a big table that we have from Thermal. As I discussed before, we have 6 different cabinet constructions that are going to meet different applications, meet different CFMs, meet different indoor outdoor use. Knockdown, if you need to get into a certain building, we have an option for that. We have many different options for panel thickness, 1 inch all the way up to 4 inch, foam and fiberglass insulation, or a combination of the two. And as I was talking about before, if you want a good R value or good sound attenuation in your unit, different bases, different types of drain pans. I talked about this earlier. I didn't really touch on it more, but I can now on the drain pans. You can have a recessed drain pan, which is going to be integral to your floor, or you can have a raised drain pan, which is going to be, it's just raised up typically 4 inches above the floor with fiberglass insulation under it. And that's just kind of changes depending on your construction style. We have some customers that even if the construction style allows for a recessed drain pan, they would prefer to have it above the floor so they can get, more insulation underneath that drain pan because it's a sloped, drain pans are going to be sloped. So one end is going to be a lot lower than the other. And if it's recessed, you really only get about 1 or 2 inches of foam under that lowest point. So you can raise your drain pan in the unit, kind of sacrifice on the bin height of your coil, but raise it and get more insulation under that drain pan, to prevent any chance of sweating or anything like that happening underneath your unit. Um, but now, yeah, with this table, if, you can look it over with all our different options and kind of open it up for questions, Tracy, on this table or anything else in the presentation.